Sine is a periodic function. You follow the graph of sine, it just wiggles up and down forever and ever. Let's try to get a sense as to why this is the case. Why does the graph of sine look like this? Why is sine moving up and down? To get some intuition for this, let's first imagine a very different situation. Let's suppose that velocity is equal to position. And I can imagine that I'm starting here and I start moving, right? And I'm going to start moving slowly at first, but as my position increases, I'm going to be moving faster and faster, right? As my position is larger and larger, my velocity becomes larger and larger, which then makes my position larger and larger. So if this is the way the world works, I'm not bouncing around from -1 to 1 like sine. I'm just being thrown off towards infinity. We know what that situation looks like. If f of t is my position at time t, then f prime of t, the derivative of f at t, is my velocity at time t. So saying that velocity equals position is just saying I've got some function whose derivative is equal to itself. And we know an example of that. F of t equals e to the t is one example of such a function. Let's try to cook up a different situation. Let's imagine something a little bit different. Instead, suppose that we're in the situation where my acceleration is negative my position. So that means that if I'm standing over here where my position is positive, I'm to the right of 0, then my acceleration is negative and I'm being pulled back towards 0. And then as I swing past towards 0, now my position is negative, so my acceleration is positive, so I'm being pulled back in the other direction. And that's kind of producing this swinging back and forth across 0. This situation comes up physically in the real world. If you attach a spring to the ceiling, the spring's acceleration is proportional to negative its displacement. There's a function also that realizes this model. To say that acceleration is negative position is to say the second derivative of my position, which is my acceleration, is negative my function. And yeah, we know an example. If f is sine of t, then the derivative of sine is cosine, and the derivative of cosine, which is the second derivative of sine, is minus sine of t. And we know another function just like this. Look, if g of t is cosine of t, then g prime of t is minus sine t. But then g double prime of t, the second derivative of cosine, it's just minus cosine of t because the derivative of sine is cosine. So cosine is another example of a function whose second derivative is negative itself. We know even more functions like this. For instance, what if f were the function f of t equals 17 sine t minus 17 cosine t? Well, then the derivative of f would be 17 times the derivative of sine, which is cosine, minus 17 times the derivative of cosine, but the derivative of cosine is minus sine, so this is plus 17 sine t. So that's the derivative of f. The second derivative of f is the derivative of the derivative. This will be 17 times the derivative of cosine, which is minus sine, plus the derivative of sine, which is cosine. So yeah, this is another example of a function whose second derivative is negative itself. If I take this function and differentiate it twice, I get negative the original function. So if you like, the reason why all of these functions are bouncing up and down like this is because in every case, the function's second derivative is negative its value. When the function's positive, the second derivative is negative, pulling it down. And when the function's value is negative, the second derivative is positive, pushing it back up. And so the function bounces up and down like this forever.